Okay, regression. Now, regression is all about taking a scatter graph and trying to draw the line which best fits the data. Okay, so for the first scatter graph here, you can see that the data is pretty well showing a positive correlation. So there is a sort of straight line that goes in this sort of direction. And first of all, I'm going to just explain the principle really of how we calculate the equation of a regression line. And this is called the method of least squares. Now, essentially, let's just say, first of all, I'm not very good at drawing a line that best fits the data. So let's say the line that I'm going to draw, let's have it in green, not very good. I'm going to draw my line of best fit. So it goes kind of like that. You can see that's pretty awful, isn't it? As a line, the data is actually going like that. That is pretty dreadful as a line of best fit. Okay, but there is, and you don't need to know this in too much detail, you can work out, or basically the formula that works out the equation basically tries to minimize these distances. So let me just put in these vertical distances, and these vertical distances, I'm not sure whether you need to know this, but they're actually called residuals. Now, if you've drawn your line of best fit that fits your data badly, then these residuals, so each of these is called a residual, and all of those residuals will be quite long because your line is nowhere near your scatter point. And in fact, what is used in the formula for working out the regression line, so that's this line here, except in this case it's not very good, is they take all of these distances, let's call them D1 and D2 and D3 and D4 and D5, what was D6 there? D6 and D7. So those are all of the residuals, and basically the best possible line will be so that D1 squared plus D2 squared plus D3 squared and so on is as small as possible. So in other words, when we are drawing the line of best fit, or what's called the regression line, what we are trying to do is keep the squares of these distances from the line as small as possible. And the method there is called the method of least squares. Okay, so let's just do it a little bit better now. Let's again draw my regression line. This time I'm going to do it a bit more sensibly, so I'm going to go probably in about that direction. And now let's draw on those residuals again. And you should be able to see, if we look at, so there's the first one, there's the second one. Okay, so here are my residuals. That one's pretty close. That one's also pretty close. So is that one, and so is this one. If we look at all of the residuals there, you can see it doesn't really make that much difference, but it should be that here, where we've got a better line that better fits the data, then these distances squared should be smaller, or the sum of those squares will be smaller than the sum of these squares. So essentially all you've got to know really is that when we are calculating the equation of our line which best fits our data, we're trying to keep the squares of these distances as small as possible, and it's called the method of least squares.